Today we are going to consider how to apply chain rule, product rule and quotient rule to find derivative of a function. How to apply chain rule? In general, there may be only two situations. When function is raised to some power, for example sine to the power of 10, it means sine x is raised to the 10th power. We just write power here, don't write brackets and don't write power here. Or it may be function without power, it means raised to the power 1, but more complicated argument, it means something different than x. When there is power, you should apply rule for derivative of x to the power of 10. 10 because here we have power of 10 and derivative of x to the power of 10 is 10x to the power of 9, and you should use rule for derivative of x to the power of 10, but instead of x you should just copy all this expression without power, so it becomes 10 sine x to the power of 9. We just write power here. And according to the chain rule, we should multiply by this expression, which is used instead of x, sine x derivative. And how to find this derivative is another problem, and it's just from data booklet. Sine x derivative is cosine, so finally it becomes 10 sine to the power of 9x cosine x. If you don't remember rule for derivative of x to the power of n, it's nx to the power of n minus 1. For example, derivative of x to the power of 5 is 5x to the power of 4. Another example. For example, ln cubed x derivative. Again, power here means that it's ln raised to the third power. There is power, so we use rule for x cubed, and x cubed derivative is 3x squared, but instead of x we just copy all this expression without power, so it is equal to 3 ln squared x, and according to chain rule we should multiply by all this expression without power, derivative ln x derivative, and again it's just given in data booklet. Derivative of ln is just 1 over x, hence it is equal to 3 ln squared x over x. And if there is no power but more complicated argument, we should use rule for the derivative of sine x. It is given in data booklet. Sine x derivative is cosine, but instead of x we should just copy all these arguments. So this derivative is equal to cosine 5x to the power of 10, and we should, according to chain rule, we should multiply by argument derivative of this expression. Derivative 5 multiplied by x to the power of 10, derivative is 50x to the power of 9, so it is equal to 50x to the power of 9 cosine 5x to the power of 10. For example, ln of 10x cubed. Notice that now this power is related to x, it is related to argument. ln is to the first power, there is no power, but more argument, more complicated argument, so we should apply rule the same as for derivative of ln x, and in data booklet it is 1 over x. and keep this argument. So we should write instead of x this argument. So derivative is equal to 1 over 10x cubed and 10x cubed derivative, argument derivative. X cubed derivative 3x squared times 10, so 30x squared over 10x cubed. It can be simplified, it's 3 over x finally. If we have both situations, it's actually beyond syllabus, but I can show, for example, if we have sine to the power of 10 of 2x squared. You should do rule for power firstly, so we apply formula for the derivative of x to the power of 10, which is equal to 10x to the power of 9, but instead of x and instead of x we just copy all these expressions without power, so derivative is 10 sine to the power of 9 of the same argument, keep same argument, and multiplied by all this function derivative sine 2x squared derivative. And how to find this derivative, it's another problem, and you can see that here must be applied again chain rule, but there is a function to the first power, or I say without power, but more complicated argument, so this derivative should be found as using sin x derivative is cosine, so it is equal to cosine 2x squared and multiplied by argument derivative, which is equal to 4x cosine 2x squared. And the final answer is 40x sine to the power of 9 2x squared cosine 2x squared. How to apply product rule? And notice that chain rule is applied when we have only one function. What do I mean? For example, if you have, for example, f of x is 2x to the power of 5 sine 10x. Here you have two functions, for example, 2x to the power of 5 and sine of 10x. You cannot apply directly for all function chain rule. You should consider as a product of two functions. We can consider it as this to be equal to u and this to be equal to v, and derivative becomes u primed v plus u v primed, which is equal to 2x to the power of 5 sine 10x plus derivative plus 2x to the power of 5 sine 10x derivative, and this derivative can be found using chain rule. So you can easily find derivatives and write the final answer. When we use quotient rule, quotient when we have division, for example, sine x over x squared. Here you can see that there is division of two functions, and we can consider as u over v, and derivative is equal to v squared u prime v minus u v prime, so it becomes sine x derivative x squared minus sine x x squared derivative over x squared squared. And you need just find derivatives and simplify and write the final answer. Here again may be situation when one function may be raised to some power or more complicated argument, and only for one function you can apply chain rule. Of course, for some situations it may be useful, but for another situations it may be not useful. You can rewrite quotient as product. You can consider this function as x to negative 2 sine x and consider as product u times v. Hence derivative is u primed v plus uv primed, which is equal to x to negative 2 derivative sine plus x to negative 2 sine x derivative, and you need just find derivatives and write the final answer. And that's all.